Hello there, so this will be our problem set number 5 for the torque. A uniform 400 Newton beam is supported as shown below. Find the tension in the tie rope. So this is the figure. Basically, what are the given? Here are the given, so the weight of that beam, which is a 400 Newton, and take note of the word uniform. The weight of that object, which is 2000 Newton, is suspended at the length L. So 3L over 4 plus L over 4, that would make sense as L. And the beam, which has 50 degree right here from the figure, supporting with T at 3L over 4. So 3L over 4. What's the required? Simply the tension. Our equation is torque equals to force perpendicular multiplied to distance from the pivot. And that would also be our equation, which is torque equals sine theta multiplied to force multiplied to R. Our solution, remember that this is not moving. So therefore, according to Newton's first law, summation of all torque must be 0. So let's just first consider what are the torque components that we have. So the sum of all the torque would be the force or the weight of that beam multiplied to that distance from the pivot. The force or the weight of that object, which is this, multiplied to the distance from the pivot. And the tension from the string multiplied to R. Remember, we have to define torque as force perpendicular. So we are getting the tension which is perpendicular. Now, so we have to consider what would be the signs. Will it be positive or negative? Now, let's first consider the weight of the beam. Now, this one, the weight of the beam, it will rotate in simply, okay, clockwise direction. So what would be the sign? Positive or negative? So the sign would be, of course, that would be negative. How about for the weight of that object? So the weight of the object, so this, what could be the what could be the sign? Let's try to see. Oops. It will turn in clockwise direction, so therefore the sign would be negative. Okay, and next. So the tension of the string, it will pull the beam. Okay, so it keeps on pulling the beam. So the direction here is simply counterclockwise, and the sign would be, okay, that would be positive. So this time, let's try to plugging in all the values. So we have to plug in the values. So we have 0 equals to negative. Now, let's try first to find, will we use cosine? We're going to use sine. Let's try to see. So, let's redraw our figure. This one, this will be represented by this line. So we have here the tension to that string. And then this one would be the beam. This will be represented by this. Okay, so we have here the 50 degrees. So we have here a 50 degree angle. Now we could notice that it is also 50 degree. Why? Simply because they are alternate interior angles. And we all know that in geometry, alternate interior angles are equal. Now, so we have to draw, remember that we have to define force on the torque which is perpendicular. So therefore, we have here the 50 degree, and then this is the perpendicular force for that 50 degree. And then therefore, 50 degree, the opposite side is the tension perpendicular. So we could now predict, we're going to use sine or we're going to use cosine. So definitely that is sine. Now, so let's draw another figure. This time, we have to figure out the weight of this object. So this will be represented by this. So we have here the 2000 Newton. And then this one, this is the beam. So this is the beam. So we have here again the 50 degree. And then we have here, of course, it forms now a right triangle. And then this one is 50 degrees. So we take note that this is the force perpendicular. Okay, so that would be the force of the object's weight perpendicular to this beam. And then therefore, if we try to look at the figure, here we form 90 degrees. Okay, and then this one we form also 90 degrees. So definitely we could predict that this one is 40 degree. That's simply 90 minus 50. And this one will be 40 degree. Okay, and then therefore this will be our opposite side. So we know what function we're going to use. So therefore, we could also consider the weight of this beam, which is 400 Newton. Since this one is a uniform beam, meaning to say the weight is distributed uniformly. So we have our pivot on the center, which is simply the length divided by 2. That's why we have L over 2. Okay, so let's do now our substitution. So we have here the pivot, which is 400 N L over 2. This is the R. Okay. So we have first 400 Newton for the weight of that beam, 400 Newton times L over 2. Now, we have to apply the 400 Newton same angle principle with the 2000 Newton that we have discussed. So we're just going to put here, for example, the 400 Newton. Okay, same principle. So therefore, we still have 40 degree. Okay, so what will be our function? Would be sine 90 minus 50. So that is sine 90 minus 50, which is sine 40 degree. Okay, we have here 400 Newton times L over 2 minus, now let's focus now on the weight of the object. For this time, we have again the 2000 Newton. It's the weight of the object. So we simply have sine 90 minus 50. Okay, this is the, okay, we are getting the force perpendicular. So this is the angle multiplied to 2000 Newton. Okay, so that's it. Next, another component we have here. This is the whole. Okay, so this one is the whole L. Okay, so our R for the object's weight, since this one is suspended at the end, therefore, it is simply L over 4 plus 3L over 4. We simply have L. Okay, next, plus, of course, we all know the tension, but let's try to figure out if we're gonna use sine or cosine. So tension. Now this one is the opposite, okay, which is sine 50 degree. Okay, and then therefore multiplied to 3L over 4. Look at the figure. The distance from this up to the pivot is 3L over 4. So therefore, we could now, everything is being plugged. We could now use the mathematical solutions for us to arrive on the answer. So we have 0 is equivalent to negative sine 40 degree, 90 minus 50, and then 400 times L over 2, or simply 400 divided by 2. Then minus, of course, 90 minus 50, that is sine 40 degree, multiplied to 2000 Newton. And remember, L over 4 plus 3L over 4 is just equivalent to L. Just simply 0.25 plus 0.75, that is simply 1. And plus the tension, which is we don't know, multiplied to sine 50 degree times 3L over 4. Remember, 3L over 4 is just similar to 0.75. So 0 is equivalent to or equal to sine 40 degree times 200 Newton, that is Sine 40 degree is 1285.755 Newton multiplied to the length plus the tension sine 50 degree times 0.75 or sine 50 degree, press it in your calculator, times 3 divided by 4. And that would result to 0.5745 times T times L. Performing mathematically, so we have, okay, let me just copy the answer. Okay, so there you have it. Okay, so this part, we have to transfer it to the other side. Okay, transpose it to the other side. So therefore, the sign has been changed. Here, the 128.558 Newton times the L. So take note that they are both negative. So we simply add it. And then remain the sign. And then that's it. We have here 0.5745 times T multiplied to L is equals to 1414.313. Okay, that will be equals. Okay, divide both sides by negative 0.5745. Cancel the L, cancel the L, of course, so that will be on the other side. And then simply, the tension is equal to 2,461 Newton. And then, we have to round it off to 2,460 Newton for 3 significant figure. And that's it. That's the value of our tension.